All right, let's get started. Good evening, everyone. My name is Yingfeng Gao. I'm very happy to give you guys this presentation by using this chance. My topic of today's presentation is Industry 4.0 Smart Factory and Networked 3D Printing with Current Concept and Future Directions. First of all, I'm going to split my presentation into 4 parts. The first one is Smart Factory and Industry 4.0. The second one is 3D printing in Smart Factory. And third one, Industrial IoT, which is Internet of Things. The fourth one is Future Directions. All right, for the first part, Smart Factory and Industry 4.0. So what is Industry 4.0? We know the first industrial revolution is about air project process. The manufacturing process was being inputted more steam power and water power. And for the second revolution, electricity and combustion engine have been widely used in manufacturing. And for the third revolution, information and computer control were being introduced in manufacturing, the manufacturing process being more intelligent and smarter. And for the fourth revolution, I believe there's not only about computers, but also networks and cloud techniques. So there is 4 characteristics or you can say advantages of the smart factory. The first one is fast. The manufacturing is totally automatically with less human involved. The second one is effective. With more robotics and computer introduced, the manufacturing process could be more straightforward. And third one is economical. For the cost, smart factory could significantly reduce the cost of labor. And for the fourth one, flexible. I'm going to move to the next slides. I remember in the first lecture, Dr. Pai had told us for the manufacturing industry, the cost should be lower, quality should be improved, time and speed to market should be shorter and faster. These are the key of the manufacturing industry. So from this picture, we can see the customer service, finance, marketing, design engineering, manufacturing are all concentrated on customers. Everything is concentrated on customers. Customer feedback could also get responses from the product as quick as possible through the smart factory. Because manufacturing engineer could make changes with designers changing ideas as soon as possible. For the 3D printing in smart factory, 3D printer is very common to say, and there's 2 mainly methods, which is FDM and FFF, which is fused deposition modeling and fused filament fabrication. Actually, they are the same thing. 3D printing is no longer just a prototyping technology. The development of smart production system has caused a fundamental change in manufacturing with systems that now allow for more flexible, automated operations and cost-effective manufacturing of end-use consumer products. If we give its inherent capabilities and benefits, additive manufacturing is often touted as a revolution across industries. Yeah, of course, in smart manufacturing, additive manufacturing is also typically mentioned as one of the main Industry 4.0 technologies that have an important place in smart factory. If we consider about the software side, workflow automation is gaining traction as companies realize the achieving serial production with 3D printing will be virtually impossible without an end-to-end management system in place. All right, here's Adidas high-tech factory, additive manufacturing in smart factory. That's I remember in the second lecture, and Dr. Pai have shown us the Adidas smart factory. The Adidas smart factory could fabricate 1370 pairs of shoes per day and more than 500,000 pairs of shoes 1 year because of 3D printing introduced. Adidas high technology, so there is a solution to the time-consuming process of this stage of development. The utilization of 3D printing and scanning technologies to replace the traditional process of prototyping testing. A 3D design program can be used to design a particular product. Within the program or software, designers will be able to specify which material is used in a certain part and accurate portray delicate measurements such as like a dimension, something like that. Once a product design is ready, manufacturers and material suppliers can simply receive the scan files from the product designers printed using an interface grade 3D printer and test it. If there needs to be an improvement or change, manufacturer engineers can simply change the product's design within the program and send it to the file back to the product designer. This way, the prototype testing phase can be reduced from a few months to maybe only a few days. Because of many time-consuming operations will be overtaken by robots and the prototyping, test phase is optimized by 3D printing machines. Adidas Smart Factory believe that the Speed Factory will demonstrate unparalleled flexibility and the production speeds. There's one thing is more importantly, the resilience of robots, machines, and 3D printers instead of the human employees allows the Speed Factory to quickly adapt and changing products and manufacturing processes. For example, back to the old days, maybe in a traditional Adidas factory, the establishment needs to be shut down for a few days if it is intends to switch from model A to model B, because machines have to be reprogrammed and retooled. But for right now, in an automated environment, there are less manual processes and the machines are controlled by user-friendly interfaces. The factory will be able to switch production from one product to another almost in very short time or instantaneously. And the third part I'm going to talk is Industrial Internet of Things, which is IoT or Industrial IoT. These instruments have sensors that can collect meaningful data points on the cloud or offline database to track and identify ways to improve the manufacturing process. Industrial IoT can also improve operational efficiency or control or visibility into flexible key indicators. The cloud computing makes the factory storage, sharing, and deal with this data information at very low cost. The interconnected equipment and machines in the workshop benefit from the ability to quickly upload large amounts of data, which can be refined to provide feedback and near real-time decision-making. And same as the supply chain in smart factory, whenever there is a new information come, the supply chain could adjust and accommodate by itself, improve the manufacturing process and upgrade automatically. And if we talk about labor, for labors, with the increasing amount of robotic system joined, the labor demand will be significantly decreased. Some people believe that this may cause some social problem, but I think that is not considered by engineers, right? And for the IoT, there's three basic concepts. An IoT ecosystem consists of web-enabled smart devices that use embedded systems like processors, sensors, and communication hardware to collect, send, and act on data they acquire for their environment. IoT devices share the sensor data they collect by connecting to an IoT gateway or other edge device where data is either sent to the cloud or to be analyzed. Sometimes these devices communicate with other related to devices and act on the information they get from another one. The devices do most of work without human intervention, although people can interact with devices, for example, to set them up and give them instructions and access the data. For the future directions, for the Industrial 4.0, the Industry 4.0 is driving digital transformation across smart factories, blending computing power within the machine and the sensor technologies. And there's one thing I want to talk about is 5G, which is fifth generation mobile network will supercharge this transformation. 5G will bring faster speeds, lower latency, large bandwidths, and edge computing capabilities. The 5G smart factory of the future will center on fully connected experiences, from massive devices connectivity and innovative technology experiences to near real-time automation and network flexibility. And 5G will help bring major advancements to the smart factory, and the manufacturing company could ultimately realize major benefits like performance improvements, operational efficiencies, and increased safety. And in the future, if I was, I just have an example of like in the future, if I was a product designer, like if I live in the Washington, DC, and I can control maybe 1,000 3D printers, and I can control the whole manufacturing process in the factory where maybe located in the Africa or South America or even Asia, right? And then I believe with the 5G technology introduced in manufacturing, the smart factory must have the bright future in near soon. Because as the saying goes, the future generosity to the future is to give everything to the present. So, any questions so far? And any question for me? All right. Thanks for you guys watching, and I'm very appreciative that you guys can see my presentation.